Okay, so yesterday we did circumference. So you can tell me, circumference was around the outside of the circle. From yesterday's video, y'all can go back and watch, but we outlined the outside edge. And then we went through the whole formula for finding circumference and all that, so y'all can watch that, those of you that weren't here yesterday. Today we're talking about area. At the end of class yesterday, I had you color the inside portion of the circles. So if you look at Gavin's paper, he didn't quite get through, or he did, but he's got the outside done in pink and the inside kind of shaded in orange. The reason for that is we found circumference yesterday. What I want you to do is, when I give you your paper back, I want you to get you the two colors that you used. One for circumference, the other one was for area, right? And have the color for circumference ready, because I'm going to tell you something to do with it in just a minute, okay? So I'm going to give these back. All right, so hold up the color you used for circumference, and I want you to shade very lightly where it says C equals 2 pi r on the front. I want you to shade, highlight that. Gage, you'll have to draw a box around it because yours is, but highlight C equals 2 pi r on the front and C equals pi d on the back where we wrote the formula. Basically what you're saying to yourself is, this formula, whatever color you shaded, if this is Aisha's paper, she did the circumference in blue. So we would shade C equals 2 pi r, that same blue, and C equals pi d, that same blue. In other words, what you're saying is, this is the formula I use to find that blue for each circle, okay? All right? Because today I'm going to give you a white sheet of paper, and we're going to fold it.
What was the one on the back?
Pi d. C equals pi d.
And we do that with the...
You're going to do pi d will be the same color.
Okay.
Pi d. Everything we did yesterday was circumference. Everything we did yesterday was circumference. So all of the math that is on this piece of paper right now should be that pink color. Okay? Matter of fact, do this. Everywhere those formulas are written on your paper, I want you to shade them the color that you shaded, that you outlined in.
You're a big squirter, aren't you?
Oh, honey.
I need orange and pink. Sorry, I don't have any white crayons.
You've got the same two colors now. Use that blue. That's close enough. All right? Everywhere on your paper that those formulas are written, I want you to shade them that color.
I need a pink crayon.
Everywhere that formula is written, I want you to shade them that color. Did I give you a white sheet? Does everybody have a white sheet?
You already gave me one.
That white piece of paper that I just gave you. We're going to use this same piece of paper, and we're going to use these same circles to talk about area and talk about finding the area of a circle, and then we'll go back and do some other practice. But right now, I want you to take this piece of paper, and you're going to fold it in half once. I call this cubing, and I'm going to let you tell me why you think I call it cubing in a minute. Fold it again in half.
Do we fold it like this?
Fold your paper in half once.
But like...
Fold it. There you go. Fold it. Make it look like mine.
I know. I was wondering...
And then fold it in half again.
So once we get it here...
And then fold it one more time. Fold it again. Like this. Does it look like mine?
How many times you fold it?
I folded it 3 times. That's right, lady. And when you open it back up, how many sections you gonna have?
8.
Why do I call this cubing?
Because you fold it 3 times.
What's that have to do with anything?
When you cube a number, you multiply it 3 times by itself.
What am I multiplying 3 times by itself?
4. That's not right. 2. Sorry.
3.
Huh?
2.3.
2.3.
No, you're cubing 2.
What is cubed?
Cube is
What is the exponent for cubed?
3. You're folding it 3 times.
What am I? All right, so I'm folding it what?
You're folding it in half. 3
In
times.
half. And what?
Half.
What is half?
2. Or
So I'm
0.5.
folding it in half 3 times, and 2 to the 3rd power equals what?
8.
And how many sections do you have?
8.
That folding that piece of paper is actually exponential. That's what we call exponential growth. You're folding it in half 3 times. If I folded it another time, how many sections would you have?
4.
16.
2.
I would have 16, which means 2 to the 4th power is what?
16. Because 2 times 8 equals 16.
Well, because 2 times 2 is 4, times 2 is 8, times 2 is 16. Yes. Okay? But folding that piece of paper is an example of what we call exponential growth. And it works because you're folding it in half. What? All right, open it back up and you have 8 on the front and 8 on the back, which means we're going to do the first 8 on the front and the first 8 on the back. So we're going to do 1 through 8. And then 11, 12, 13, 14, 15, 16, 17, and 18. Okay? And on the back. Now, your circles yesterday were outlined, right? But today we're doing area. Today we're doing area. Yesterday, we outlined our circle to do circumference, right? Today, we're doing area. The area of a circle is what's on the inside. Okay? The area is the inside. So, the formula for finding circumference, let me do this again a minute. I'm going to highlight this green on the inside. So that I can write it green. And then I'm going to write it green. So, area. The area of a circle is pi r squared. And we're going to do pi r squared on the front. Why are we doing pi r squared on the front? All those circles on the front are giving you what?
Right. Radius.
Yes, this is your radius. This is a radius. This is r. And we labeled that yesterday. We labeled this r yesterday. That's r. So we're given the radius. So we're going to use pi r squared on the front. Okay? So whatever color you shaded on the front, I want you to write on your white sheet of paper. On your white sheet of paper, I want you to write number 1 through 8. So on your white sheet of paper, you got 8 sections. Did most of you lay it in front of you? How did you do it? I'm going to do mine this way just because it'll be easier, but you don't have to. So, you got 8 sections on the front. Whether you lay it landscape or portrait, it doesn't matter. And we're gonna number 1 to 8. And you're going to go ahead and write A equals pi r squared. You're writing that with your pencil. If I write A equals pi r squared down for all of these. Okay? And then we're going to come back and make sure all of these are highlighted, whatever color you used to shade your circle. Color code this back to that paper that's got your circles colored. So Gavin has his circles colored in orange, so Gavin would shade in orange. Okay? What you're telling yourself is, this is the formula I use to find this colored portion of the circle. Okay? And using these colors will help you kind of differentiate a little bit between this. Alright?
So we do the color we
The color you colored it in. Because now we're looking at the area. Now we're looking at the area. You've got two different formulas. One gives you circumference around the outside. One gives you actually have 4 formulas. 2 for circumference, 2 for area. The 2 for circumference, 1 is for using, what I need to do on this tree map that I showed you yesterday, what I need to do on this, for circumference, the main formula is C equals pi d. That's the one you're going to see on formula sheets. That's the go-to. And we talked yesterday about why 2 pi r works. Today, your go-to formula, the one that will be on formula sheets, is going to be pi r squared. Okay, for area, pi r squared. But you've also got pi times 1/2 d. Because to get and we'll use that on the back in just a minute. Okay? Right now we're using pi r squared. So now, looking at number 1. The circle for number 1 gives you a radius of what?
11.
What is r on number 1? No, it's not.
No, that's circumference. 11's the radius.
The 11 is the radius. The 11 is the radius. So, A equals pi. We're going to go ahead and just use 3.14 for pi today. Okay? We're not going to use the pi symbol on the calculator. We're going to put in 3.14 times 11 squared. So that's 3.14 times 121. Which is 379 so A equals 379.94. And I think your directions said to round to the nearest tenth, which is going to be 379.9. Because it told you to round to the nearest tenth. We're going to use 3.14. Everybody's going to use 3.14 for pi.
So when we do the thing, do we have to put the 379.94?
No. No. You can go straight from here to here. Okay?
Are we shading all of that too, or just the top part?
Just the formula.
Okay.
Any questions about those?
No. So that's it. We just have to like.
Okay? That everybody good with that?
Mm-hmm.
All right, flip it over. Flip your white sheet of paper over, number 11 to 18 on the back. So this is number 11. Now on the back, all of the circles on the back are giving you a what?
Diameter.
Right. That line goes all the way across, doesn't it? So on the back, we're going to use A equals 1/2. Well, A equals pi. Hang on. Pi times. One half D squared. Because 1/2 of D is R. Okay? 1/2 of D is R. But because we're given the diameter, we got to get half the diameter. We got to take half the diameter, square it, and then multiply it by pi. Okay?
Okay, I understand.
So you're going to still take that same color that you used to color in your circles and highlight that formula, because that formula is still going to find you the area. Okay? So Colton's circles are highlighted in yellow. They're colored in yellow. So that same formula is going. So this piece of paper that's folded front and back, we're using that same color, because it's all about the area. So in Colton's brain now, area is yellow to him, and circumference is purple. Okay? In Abby's brain, area is somewhere between a blue and a pink. Blue. And circumference is kind of a dark pink purple. On Aisha's paper, area was yellow. Area is yellow, and circumference is blue. Okay? In her brain, area is yellow, so in your brain, you should start to see those colors when you see, and I'm hoping that's going to help you differentiate when we're reading word problems and that kind of thing. Okay?
Do we put this down on all of them too?
Yes, you're going to write this formula for all of them and highlight it for all of them. I'm not going to do it on all of them right now, but you're going to. Okay? Let's go ahead and work number 11, and then I'm going to turn you loose. Okay? Let's work number 11. So on number 11, what is the diameter?
4.
Huh?
4 meters.
The diameter is 4, so I have A equals 3.14 times 1/2 times, you're going to have to show that as multiplication, okay? 4 squared. So we have 3.14 times 1/2 of 4 is 2 squared. 3.14 times 4.
Yeah.
I thought you were supposed to do the exponents first.
Well, what's 4 squared?
16,
And half of that's what?
8.
Hang on. You're right, Colton, in the way that you're thinking, but the way this is written, let's go back and rewrite this a little bit. Let me show you why that. 3.14 times 1/2 times 4 squared. Let's do it like that. You got to do what's in parentheses before you do what's in the exponent. And 1/2 of 4 is in those parentheses. And the way I had it written, it wasn't clear that way. So let's do it that way. So 3.14 times 2 squared is 3.14 times 4. Which is 12.56. Which will round to 12.6. Okay, so write this multiplication right here with a dot so that you know, so that you can remember you've got to do what's in those parentheses before you square it. Okay? Questions?
This might be.
Do you have a pencil? Okay, make sure you're doing all your math with a pencil and just shading with the crayon.
This might be a little confusing, but how come we don't use 360 since there's 360 degrees of a circle?
I'm gonna put a video in because that's degrees. We're working in radian. We're not working in degrees. And I'll put a video. There's a video that we watched yesterday that kind of goes through that just a little bit on why pi works. But we're not working in degrees. We're working in radian, which you will get into more when you get into more advanced geometry and the unit circle.
Okay.
Huh? All right, any questions?